All of these are going to be using straight, sine, cosine, or tangent. We're not technically solving for whatever's there. Okay, so sine, just for a quick reminder, you can write this either at the top or at the middle, it doesn't matter. Sine is so O over H. Most of the time you'll just see one letter. Most of the time you'll just see one letter. So sine is opposite over hypotenuse, cosine is A over H, tangent is O over A. Okay, so what I want us to practice doing, theta can be a number of things. In this case, theta is standing for A. Okay, so what does that mean? That means I need to find the sine of A. Well, A is wherever it is in that corner. So this is talking about A right here. This is talking about B, and then C is the 90-degree angle. I don't know what A and B are. I know it's 90. I don't know what these two are. That's why we need trig. So if I'm finding sine of A, you want to write it again so it's in the picture? So, ka, toa. So sine of A is going to be opposite. So what's opposite of this A? 4. 4, opposite leg. I'm talking about legs now. Okay? A, opposite is 4. This 3 would be considered what? Adjacent. And this 5 is hypotenuse. So for sine of A, we need to put opposite, which is 4, over hypotenuse. Sine of A, we're just setting this up. We're not solving for A yet. We're just setting it up. Okay, what's sine of B? Here's B. What's opposite of B? And what's the hypotenuse? Good. Okay, we're just practice setting these up. Cosine. Cosine of A. So now I'm finding adjacent over hypotenuse. So adjacent to A is 3. Hypotenuse of A is 5. I'm just going out on every other one because I didn't leave enough room. Cosine of B. Here's B. Cosine is adjacent over hypotenuse. So adjacent, which one's that going to be? Good. It's not opposite. 3 is considered opposite. 5 is hypotenuse. 4 is adjacent. So adjacent over your hypotenuse, which is still 5.
Does the hypotenuse ever change?
It's always the largest one. Tangent of A. Tangent is opposite over adjacent. Opposite is 4. Adjacent is 3. Opposite over adjacent. Tangent of B. Opposite of B is 3 over adjacent, which is 4. Okay. I want you to practice doing this box right here. Sine, cosine, tangent. Just set it up. Don't solve for A, just set it up.
How do you know which one's A?
Oh, let's see. Let's just make one of these A. Up here at the top? Okay. This is A. Sorry. Ethan, what did you get for sine of A? 30 over 34. So opposite over hypotenuse. Good. Cosine of A. Aubrey. Say that again. 15 over 34. Cosine of A. So this is A. Cosine is adjacent, which is 15 over hypotenuse, which is 34. Good. Tangent. Emma Huner. 30 over 15. Just getting easier to set it up? Okay. I want you to do... I don't really want to waste time on that. Okay. Let's go here. Let's go here. Now we're actually going to start solving and using sine, cosine, and tangent in our calculator. So get out your calculator. I know mine's fancy. It doesn't have to be. Okay? You need to make sure your calculator is in degrees. First thing you need to do. Do y'all know how to do that? Me either. Let's figure it out. DEL?
No, DRG.
DRG? Okay. Click DRG, and then it's going to show degrees, radians, or GRD. You should make sure it's already in degrees. Check. Is everybody good? Okay, I press DRG, this number right here, and then it should be in degrees. Alright, so let's practice. This is just straight sine, not inverse. So press sine, and then plug in this number, 35 degrees, equals, and then it says to round to 4 decimal places, so 0.5736. Okay, we're just practicing using these trig functions on our calculator. So sine of 35 degrees is 0.5736. Tangent of 35 degrees, 0.7002.
What if it's negative?
It's okay, right there. Okay, check yours with mine. Remember how I said that it's really hard to do these in your head? Because did you see what kind of answers we got? But I also said that some of these will be special cases that you'll be able to memorize. What do you think one of those special cases is? Huh? Tangent of 45, which is 1. Yes, Dalton?
Are we supposed to go round?
Yes, you're supposed to round to the 4th. Did I not round 1 correctly?
Well, just for number 7, I got 5 or 0.577.
Cosine of 45.
Yeah, 150.
For number 7, tangent of 150. 0.577. I got 0.35, which I would have rounded to 4. But, I mean, it's not a big deal. All right, let's start putting these to work, to use for application. Finding angle measures of right triangles using trig. Use a calculator to find the measure of angle B. So here's angle B. Most of the time, if A and B and C are big on the outside, when you're talking about their angles, they're going to be little. So I could write this angle as little a, little b, and little c. You don't have to be that in-depth. I was just telling you. So I want to find the measure of angle B. Well, here's B. But what do I know? What is this side considered? Hypotenuse. And what is this one considered? Not opposite. Adjacent. This is considered adjacent. This is considered hypotenuse. opposite, Lucy, would have been this one, because it's opposite of B. Okay, so using your Indian, so, ka, toa, which one will allow me to find the answer if I have a hypotenuse and adjacent? Cosine. Good, Ethan. Cosine. So to find the cosine of angle B, that's like cosine theta,
Why are we using cosine?
because I have hypotenuse as a number. I know hypotenuse and I know adjacent. I don't know opposite. So I need to use a trig function that has hypotenuse and adjacent. And that's the only one.
Oh,
Okay?
okay.
Cosine of B is going to be found by putting adjacent over hypotenuse. Well, when I plug those in, adjacent was 6 over hypotenuse, which is 18. But I can't just say, oh, well, B is going to be 16 divided by 18. That's it. What do I have to do? Get it by itself. I have to get B by itself, which means I have to divide by cosine, which turns it to be cosine inverse of 6 over 18. Now, to do inverse on your calculator. Y'all ready? Okay. You have to do second, and then wherever your cosine button that you pressed earlier, press second cosine, and it should show up cosine inverse. Now plug in your fraction, 6 divided by 18. So B is equal to, and I'm going to round it to 170.5 degrees.
It has to be in degrees.
Because we're talking about degrees. That's what triangles have, degrees on the inside.
Oh, no.
Okay, let's try another one. I'm still finding B, which in this case they've labeled it as X. So let's find out what we know. What is this leg considered to be? Hypotenuse. This is hypotenuse because it's the longest side. And then the one that is touching it but is not hypotenuse is adjacent. That's all right. This is the trickiest part. Adjacent. And then this over here, which we don't need, but I want you to know, would be opposite. I'm going to cross that out because we don't need it. We only need 15 and 12. Why did I pick those two sides? Because they're given to us. That's the only numbers we know. So we know 12 and we know 15. So that is adjacent and hypotenuse. So which part of these, adjacent, hypotenuse, which one? Cosine. So cosine of X is going to be equal to adjacent over hypotenuse. When you plug those in, you'll get cosine of X is equal to adjacent is 12, hypotenuse is 15. Now I have to do the inverse. So cosine inverse to get X by itself is going to be 12 over 15. So X is equal to what? 36.9? Is that what y'all got? All right, one more together. We're finding, do y'all want to find A in this case? Because it keeps telling me to find B, but then it put X here. So let's find X in this case. So let's label what we know. What's 19? Opposite. 22 is adjacent. Which trig function has opposite and adjacent? Tangent. So tangent of X is going to give me opposite over adjacent. So tangent of X is equal to 19 over 22. To find X, you have to take the inverse of tangent. So second tangent